All right, this was going to be fast because I just want to show you guys some quick shortcuts about quadratics that you guys should have figured out by now without explicit instruction. Okay, so first of all, this is a quadratic function. It is the mother function. Okay, that's why I named him M. All right, so the first thing we got to know about quadratic functions is their vertex. The vertex is the most important point of the quadratic function. It's located right here in the center of the parabola. The next thing is the axis of symmetry. In this case, our axis of symmetry equals 0 because it's right in the center of our parabola. Okay, some call it the middle x. Next is the max and min. The max and min is a y value. You're going to get it from this axis, okay, this vertical axis. And so the question is, are these y values right here on our graph? And the answer is no, they're not. They're not on our graph. In fact, these ones are. And the reason why they are is because when you look at each of these y values, they're on this graph. If you made a table of values, all of the y values, all the positive y values, no negative ones for this graph would be on our graph. And the minimum y value in this case is 0. And that's important to note because this quadratic function goes upward, and so that means it has a minimum. If it were to go downward, then it would have a maximum, which we'll see later in another graph. Okay, so now what about the y-intercept? The y-intercept is also pretty important, and the reason why he's important is because he's easy. The y-intercept in this one is 0, 0. It crosses the y-axis, the line right here, the parabola crosses the y-axis right here at the origin, so that is known as the y-intercept. All right, so another thing that you should know is the y, or the axis of symmetry, tells us that the other side of the axis of symmetry mirrors. So they mirror each other. So if you know this point right here, then you know this point. If you know this point right here, then you know this point. Okay, and that's how it works. That's how the axis of symmetry works. That's why when you guys are given a task to graph a quadratic function, you only really need the vertex, which is this guy, and one other point. That's all you need. You need 2 points, because once you get 2 points, you can just copy that point over there, and then you have a general idea of what your parabola looks like. Okay, so now for the quadratic functions, there's 2 different forms. There's vertex form and there's standard form. Actually, there's 3, but we haven't seen the factored form yet. We're going to see that in the next unit. So if we were looking at this function right here, if I wanted to make this guy look like vertex form, I would have to show you guys the numbers that we would say are invisible because we don't need them. Like, we don't need -0, we don't need +0. Those are silly numbers to put on there because they're not doing anything. Same with multiplying by 1. But it's just so you guys are getting used to the vertex form, you should know that the A is 1, the H is 0, and the K is 0. And the cool thing about vertex form is that it corresponds with the vertex. So that means the H and the K right here are the vertex for this quadratic function. The other one is the standard form. And standard form is not that useful when it comes to graphing, but we can still use it. Okay, so it's important to know that the A right here is 1, the B is 0, and the C is 0. And that's the mother function when we're talking about shortcuts. All right, let me show you the next thing. Now let's look at a shifted quadratic, okay? So we have our mother function over here, and we have a shifted quadratic function over here. These 2 quadratic functions are exactly the same. One is in vertex form, the other is in standard form. Okay, so the most important parts of the quadratic function are the vertex, axis of symmetry, and max and min. Okay, so the vertex right here is 2, 1, and you can see that that matches numbers in our vertex form. Please notice that this is a positive 2, not a negative 2. The next thing is the axis of symmetry. The axis of symmetry for this one is x equals 2, right down the middle of the parabola. And again, it corresponds to a number in our vertex form. Next is our minimum, our max or min. In this case, it's a minimum because we're opened upward. And we know we're opened upward because the A is positive. It's a positive 1. He's invisible. And so is the A over here in standard form. So our minimum is 1. And we can see our vertex and our axis of symmetry in our vertex form. So how do we graph a standard form? Well, that's kind of a little bit more work. You need to have the axis of symmetry formula. So if you don't have this memorized, you must memorize it. Negative b over 2a. You need negative b over 2a to find the axis of symmetry, or the x in the vertex. Okay, so the vertex and the axis of symmetry can easily be seen in the vertex form. But for the standard form, you need to plug in the b and the a, which in this case is the b is -4 and the a is 1, into this formula to get the 2. Okay, next thing you got to know is the other point, the point right next to the vertex, is simply 1 to the right and 1 up for each of the mother function and for our shifted function. And that's a cool pattern to recognize. And this is true because the a is 1. The a is 1 for that. Whenever the a is 1, that's going to be the pattern. And then you can easily copy the other point on the other side of the axis of symmetry right here, and then you can graph it. Okay, and you can do the same thing on the shifted one. Last thing I want to talk about is the y-intercept. This is very helpful for some functions, not all functions. The y-intercept is one of the easiest points to find because you're plugging 0 into the x. If you were to plug 0 into the x's for this form and this form, this is what it would look like. And for this graph, if you were to plug it in, you would get 5. Now, which form can you easily see that you're going to get 5 for the y-intercept? The vertex form or the standard form? The standard form, that's right, because the 5 is already there. Over here, you have a little bit more work to do to see that it's going to be a 5. Now, I've told you guys, you only need 2 points to graph. You need the vertex and one other point. You can find this point, which was easy to find because we know that a equals 1. You had to go right 1, up 1 to get to it. Or you can use the vertex and the y-intercept. See, if I had the vertex and the y-intercept, I can easily graph these points right here because this one is copied over from that one because of the axis of symmetry, and there's your vertex. You'll always need your vertex, and then you can easily graph it. All right, this is the end of part 1. Part 2 looks at 3 other graphs with different a's, and so you guys can see what the a's do to your graph.